Okay, so today we move on to the next part of the chapter, next part of the topic, that is the reactions of organic compounds, and we move on to carboxylic acids, and we talk about the acid-base properties of carboxylic acids. The first question that I want to ask you guys, and I want you to think on, is you have to write an equation of any carboxylic acid to demonstrate its acidic properties. So I'm looking for a chemical equation which would show how is a carboxylic acid an acid, how does it behave uh, as an acid. So I'll give you 1 minute. It's a pretty easy reaction, so could you please write that down? So as you can see below, actually I asked the students for the reactions, and the reactions that I got was, one was for propanoic acid plus water, which would have given propanoate propan H3O positive and the propanoate ion, and ethanoic acid plus water would give you H3O positive and ethanoate ion. What I decided was that instead of writing those reactions individually, I'd write a general equation. So I wrote for carboxylic acid, I wrote RCOOH, where R is an where R is a substituent. It's an alkyl group. Alkyl group. And that alkyl group could be methyl, ethyl, could be anything. Methyl, ethyl, and so on and so forth. The next question related to this is how would you write the following word equations? So you have to complete the word equations and also write the chemical equations for each one of them, a balanced chemical equation and a word equation. So the first one is zinc plus ethanoic acid. So I'll give you about 30 seconds to think about what you're going to write about this. Thanks. Okay, so the completed word equation that I got from the students was zinc plus ethanoic acid gives zinc ethanoate plus hydrogen gas. And that's pretty simple because you already learned in year 11 that a metal with an acid metal reacts with an acid to give a hydrogen gas. So nothing changes for ethanoic acid for that matter, because ethanoic acid is also just an acid and zinc is just a metal. So you'd get the same thing. And then we wrote the chemical equation. Now this is where there was a slight confusion. There's a CH3COO negative, there's Zn2 positive. The chemical compound that they'll form as a result is CH3COO whole twice Zn plus the hydrogen gas. So you just need to be mindful of swapping of the valencies, and that's pretty much it. So if you can keep be mindful of this, you should be fine. So let's try another one. Sodium hydroxide plus ethanoic acid. So you just need to go back to what you learned in year 11. What would happen if a base combined with an acid? I'm going to pause this and I'm going to wait for the others to get this done. So I'll give you a minute again. Thanks. Okay, so the students gave me the answer for this one as sodium ethanoate plus water, and this you just need to go back to year 11 and study the reaction that we did when a base combines with an acid to give salt and water. So this is your salt, sodium ethanoate, and this is water. Now the chemical equation translates to NaOH plus CH3COOH plus gives NaCH3COO. Now you can write this in either way. You can write this as CH3COONA, which is contrary to what we write for inorganic compounds. So if it was NaOH plus HCl, you would have written NaCl. But in this case, you could even write it the other way around. But in inorganic compounds, that means NaCl, you would never write ClNa. You always place the cation first. So both cases are fine. We do use this quite a lot, and you'll see this in your textbooks, in your university textbooks next year. So don't just, both are acceptable. Just remember, when it comes to organic compounds, both are acceptable. Now the next question is nickel carbonate plus ethanoic acid, and you have to write a word equation for that. I'll give you another minute to think about it, and we'll start discussing after that. Thanks. So if you remember from year 11, whenever a carbonate combined with an acid, it gave you carbon dioxide, water, and the salt. And that's what's exactly happening here. You're getting nickel ethanoate, which is the salt. you're getting carbon dioxide and you're getting water, and a chemical equation written for that would be NiCO3, 2CH3COOH, that's the nickel ethanoate, water and carbon dioxide. You're left with, oh, we're left with one more question before we move on to practicing questions from the set. And this question is that often we use sodium hydrogen carbonate to distinguish an acid from an organic compound. Why do we do that? And just why would we use NaCO3 and nothing else? So have a think through this. I'll give you a minute. So the reason we use sodium carbonate to distinguish between a carboxylic acid and an organic compound is that if you sprinkle sodium hydrogen carbonate, which is sodium bicarbonate, which is basically baking powder, baking soda, if you add it to your mixture of organic compounds, if an acid is present, the acid would react with the sodium hydrogen carbonate to give carbon dioxide, and that would be responsible for the fizzing reaction. So just write that NaHCO3 reacts with carboxylic acid, what am I doing? Carboxylic. That was right. Sorry. Carboxylic acid to produce CO2, which is responsible for fizzing. Now, if this turned up in an exam, it would be something like, how would you distinguish between an alcohol and an aldehyde and a carboxylic acid? What is the test that you'd use to distinguish between an aldehyde and carboxylic acid and support your answer with a reaction? That's 2 marks straight away. So this is how you can expect the question to turn up in an exam. Now, what do you need to do? Attempt set 18, 1, 2, 3, 4. So you're in a position to do 1, 2, 3, 4. So go ahead, have fun. Okay, now let's move on to the next bit, which is the esterification. It is, and don't laugh, the most important concept in this chapter. You have to complete the word equation when butanoic acid combines with butyl alcohol. You have sulfuric acid as the dehydrating agent, so that would just eliminate the water. So what would you get? What 2 products will you get? So I'll give you a minute to think about that, a couple of minutes, and then we'll move on. Okay, so what I've done is I've drawn the 2 molecules. That's butanoic acid. Please excuse me for not drawing the hydrogens here, but I'm in a hurry. And butanol. When you combine them both, you will eliminate the water molecule, as I've just shown here, and you will get this chemical, this molecule, which is an ester. And what's the name of the ester? We would name this as the substituent, which is butyl, and then this would be the parent chain name, which is butanoate. That's it. So butyl butanoate.
Is H2SO4
the H2SO4, good question, Chloe, is the dehydrating agent. It takes the water away. Hydrating agent eliminates the water. So you see that we eliminated water here. That was because of H2SO4. Eliminates water. And so can we come up with a general equation? A general equation for this chemical reaction, and that would be RC double bond OOH plus OH CH2R would give you the ester. But be careful, there has to be sulfuric acid to make this reaction possible. H2SO4 should give you the ester, which is R C double bond O O C H 2 R. R1 and R2, sorry. This would be R2 because they don't necessarily have to be the same. Now, in the case that I showed you, the butyl alcohol with the butanoic acid, sorry, butanol with the butanoic acid, that was the same, but R1 and R2 don't necessarily have to be the same. R1 and R2 plus H2O. So an alcohol combines with a carboxylic acid to give ester and water. Now that being done, we can now attempt question 5, 6, 7. This would be your homework as well as your classwork in the next 5 minutes. So have fun doing those, and we'll go on to the last part of this topic called soap formation, ester hydrolysis and soap formation in the next class, and then we're done with this chapter and we'll move to empirical formula. Thanks.